Hey everyone, welcome back to the channel. This is part 4 of a series regarding all things related to logarithms. In today's video, we're going to be going over laws of logarithms or properties of logarithms. By the end of this video, you'll understand the product, quotient, power, and change of base formula, where they come from, how to use it, and we'll go over a bunch of example problems on practicing what we've just learned. If you guys like this content, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. Alright, let's get started. So there's a few different laws and properties that relate to logarithms and kind of the manipulation of logarithms. So recall some of the exponential laws here. So if we have a number to the power of x and another number to the power of y, if we multiply those together, as long as they have the same base, we will get an expression that is ax plus y. So this base, a to the power of x plus y. That's when the same base are multiplied together, and then we just add the exponents. So that would be the product rule for the exponential laws. The next one is the quotient law. So we have a to the power of x divided by a to the power of y. So note that the base is the same here, and this will turn to a to the power of x minus y, and that would be the quotient law. And finally, we have the power law. So a to the power of x all to the power of y, that ends up being a to the power of xy. So this is really important to note because we know that logarithms are actually just exponents. They're just written in a different way. They're the inverse expression of an exponent. Some examples here would be, say we had a is equal to 2, x is 3, and y is 4. If we were to use 2 to the power of 3 times 2 to the power of 4, this would equal 2 to the power of 7. That would be an example of the product law. If we did the quotient law, it would be 2 to the power of 3 divided by 2 to the power of 4. This would be 2 to the power of negative 1 because it would be 3 minus 4. So we could write that as 1 over 2. Finally, we have the the power law. This would be 2 to the power of 3 all to the power of 4. And this would equal 2 to the power of 12. So it's this 4 being distributed into this 3 here. So to show the logarithm versions of these, we can derive kind of the product law, the quotient law, and the power law. So to do this, we're going to say that m is equal to a to the power of x, and that n is equal to a to the power of y. So for the product law, if we have log of mn of base a, this is going to be equal to log of base a, and then inside, if we substitute the ax and the ay, we'll have ax multiplied by ay. That is now what's in the logarithm part of this function. If we continue this down, I can rewrite log of a, and this will be a. Now we're doing, since it's the same base, so this is an exponent law, we can just do x plus y in the exponent. So a to the power of x times a to the power of y is just a to the power of x plus y. And note what a logarithm really is. So we're saying, if we read it like an exponential function or expression, we're going to say that to what power must I raise a to get a to the power of x plus y, right? So of base a, so a to the power of what equals a to the power of x plus y. Well, of course, in this case, that would be x plus y. Now that we have x plus y, what I can do here is I can rewrite this form. So this can turn into x is equal to log of a m. So log of m base a. And over here, this would be y is equal to log of a n. And now we can just sub those in for our x's and y's. So this is going to be log of a m plus log of a n. And note what this is all equal to. So this is now log of a mn is equal to log of a m plus log of a n. And this is our product rule right here. Now we're going to do a very similar process to find the quotient law. So this I'm going to rewrite in terms of our m and our m and n. So this is a to the power of x over a to the power of y. Again, if I rewrite this using our exponent law properties, this can be written as ax minus y. Finally, we will get, if it's a to the power of something is going to give us a to the power of x minus y, that something is clearly just x minus y. So that's what these kind of things cancel right here, and we just get this x minus y term. Now we can look at our logarithm way of writing x's and y's. So this is log am and log an. So we could say that this is log of am minus log of an. Now the entire expression would be log of m divided by n of base a is log of m base a minus log of n base a. And that would be the quotient law right here. So now for the power law, we have log of m to the power of n of base a. So what I'm going to do is I'm going to sub in our m value. So this is going to turn into log, it's going to be base a, and it's a to the x because that's our m value. And then that is to the power of n. Now I can use our power law for exponents, where we multiply this n and x together. So now this expression turns into this, where n and x are on top here. Now again, we can look at what this is really saying. So it's saying, to what power must I raise a to get a to the power of n of x? Well, that would just be n of x. And we know if we have x, we can write it as our logarithm value. So here, this is going to turn into n multiplied by log of am. So now if we write this entire expression, we can say log of m power of n base a is equal to n log of am. So what we're effectively doing is we're bringing this n out in front, and it becomes the same expression. Okay, so those are our three laws there that kind of connect our exponential laws. But there's also another important law called the change of base formula. So this one states that log of x of base a is equal to log of x of base b divided by log of a base b. So this is really important when we're looking at an equation that's log, say this one here. We have log of 4 base 3. Well, there's no base 3 for your logarithm in your calculator, and you can't really find it that easily. But what we can do is change the base to something we know, so then we can evaluate it. So in this case, it's going to be log of 4, and the common term here, this b term, is going to be 10. So here we're going to have log of 4 base 10 divided by log of 3 base 10. And that is something we can evaluate in our calculator. So to get this formula and this change of base formula, we're going to say y is equal to log of x base a. So what we're going to say is I could rewrite this to be, if I rewrite this logarithm, a to the power of y is equal to x. Now at this point, what I can do is take the log of base b of both sides. So this is a to the power of y is equal to log of x, and then it's base b again. So that's totally fine to do. We took the logarithm of both sides of the equation. And now what we'll do it over here. We have to use our power law. So I'm going to bring this y out in front. So y multiplied by log of a base b. And this is all equal to log of bx. So now I'm just looking to get the y by itself. So what I'm going to do is divide both sides by log of a base b. At this point, this side will cancel here, so we'll get y is equal to log of x base b divided by log of a base b. And remember what we said y was. Y is just equal to log of x base a. So now we have this function here where it's log of x base a is equal to log of x base b divided by log of a base b. And that is our change of base formula. Okay, so now we can move on to the problems. Now that we know all of our, formulas to use, all the laws and properties of logarithms, now we can actually start evaluating these logarithms. So here we have log of 5 to the power of 3 base 25. So what you're going to kind of find is a common theme when evaluating logarithms is we want this part of the logarithm, so kind of what's inside the brackets here, we want that to equal the base. And the reason we want it to equal the base is it's very easy to solve that. If I said, what is log of 2 base 2, that's saying, to what power must I raise 2 for me to get 2? And that's obviously 1. So if you get the base to equal whatever in here, what's going to happen is you will get the value that's just going to equal 1, and then things will cancel. So in this case, I want 25 in here. So I'm going to have log base 25, and then if I write 5 squared times 3 over 2, that's the equivalent expression of what I just did, right? Because if I multiply this term in, which is kind of the properties of an exponential function here, an exponential expression, the 2's will cancel, and I'll get 5 to the power of 3. Now the reason I do that is now I can say log of 25, and 5 squared, that's really just 25. And that's all to the power of 3 over 2. So now I can look at this expression, and I can bring this in front, right? Because that's the power rule right there. So that'll be 3 over 2 log of 25, or log of 25 base 25. So again, we're saying 25 to what power will give us 25? That is obviously 1. So our answer ends up being 3 over 2. For part B, we have log of base 2, root 36 minus log of base 2, root 72. So here, we have something with the same base, and it's being subtracted. So this is going to be the quotient law. So what I can do here is say log of base 2, and I can write 36 divided by root 72. Now at this point, since they're both square rooted, I can put that to an exponent. So I can say 36 over 72, and then raise all of that to 1/2. Because when you're raising exponents of fractions, this is just going to be brought into each component of this fraction, the numerator and the denominator. So now at this point, I can bring this 1/2 out front. So this is 1/2 log of 2, and this is going to be, well, 36 is really just half of 72. So this is going to be 1/2 right here. And now, even though this base and this kind of expression inside the logarithm aren't exactly the same, they're very close, so they involve the same base. So now we say, to what power must I raise 2 to get 1/2? And that's actually going to be to -1. So if I write 2 to the power of -1, that is the same as 1 over 2. So this evaluates to -1 here. We're going to have 1/2 times -1. This will all equal -1 over 2. And now we have our last question here, where we have a bunch of different expressions, or one expression with multiple terms in it, and they're all to the base of 8. So that's a good thing. When they're the same base, we can use these properties very easily. So here we have the product rule, because we're adding these. So again, it's that log of mn is equal to log of m plus log of n. So before we do that though, I'm going to put all of these expressions inside the logarithm. So this 3, I'm going to bring back up in front. So this is log of 8, 2 to the power of 3. And then this would be log of 8, and this would be 16 to the power of 1/2. So at this point, I can kind of evaluate some of these to make my life a little bit easier. So I can do, this one I'm just going to keep the same. But here, 2 to the power of 3, that's really just 8. So log 8, 8 right there. And then here we have log base 8, and then 16, the square root of 16, or 16 to 1/2. Well, I know that's just really 4. So now that I'm at this point, I'm going to now use the product rule because we're adding these together, and it's all the same base. So this is going to be log 8, and then inside here will be 2 times 8 times 4. So if we do all that, we'll get 16 times 4, so this will be 64. And again, I want the inside of this to be the same as the base. So this is log 8 squared. Because 8 squared is equal to 64. Now again, I'm going to bring this 2 in front, and this will be 2 log 8 of 8. So if we go over here, this really just cancels out to 1, because I'm saying again, to what power must I raise 8 to get 8? So this answer ends up just being 2. So this entire expression just gets evaluated to equal 2. Thanks for taking the time to watch this video. If you guys like this video, I'd really appreciate you liking the video and subscribing to the channel to see more videos just like this. If you have any suggestions of what content you want me to cover next, let me know down in the comments below. Thanks again, and I'll see you guys in the next video.